In this video, we are going to look at another part of section 3.5 on combinations. Now, a combination is a selection of objects in which order of the selection does not matter. So think about if you're ordering a pizza and you have 12 items to choose from, and you're going to select extra cheese, pepperoni, and mushrooms. It doesn't really matter the order at which you place those items on your pizza. So that would be an example of combination in which order does not matter. So the number of combinations of n things taken r at a time is written this way. A combination nr, just kind of like the permutation, or you could have the n subscript with the capital C and then the r subscript. And the way you figure it out is very similar. You're going to take n factorial divided by r factorial times n minus r factorial. So again, many calculators will calculate the combinations directly, and we will show you how to do that in a separate video. If we look at example 8, here we have a student has a summer reading list of 8 books. The student must read 5 of the books before the end of the summer. In how many ways can the student read 5 of the 8 books? In this case, it does not seem to imply that the order of the books matters. So this would be a combination of 8 books chosen 5 at a time. The way we would use the formula is we would say 8 factorial divided by 5 factorial times 8 minus 5 factorial. So the n number is the total number, in this case 8, and the r number is the 5. So that's what this would look like here. So this, of course, would be 8 factorial over 5 times 5 factorial times 3 factorial. Let's share the screen for how we would do that on Desmos. So we would go to functions here on Desmos, and there's a combination right here. So we type that, and then we have 8 choices. So we have to go back to main to get to numbers. So at 8, 5, and it gives us 56. So let's go back to our notes, put that in. So we get 56. Now, if we had done it by hand, this is the old school way to do it. But you have 8 factorial in the numerator, which is represented in the numerator of the fraction here. 5 factorial is right here. 3 factorial is right here. You'll notice that you can cancel out numbers, and 3 times 2 times 1 is 6, so that cancels here. 8 times 7 is 56. Super slick. You could do it by hand. Let's try this next example. In example 9, it says a child wants to pick 3 different pieces of Halloween candy to take to her school in her lunchbox. If there are 13 different pieces of candy to choose from, in how many ways can she pick 3 pieces? All right, use your math skills, and let's see what you get for this one. So since the order of the candy clearly doesn't matter here, once again, this is a combination of 13 choose 3. So this is one way we can write it, or we can write C parentheses 13, 3. Using our calculator or Desmos, we can find the answer 286. Different ways she could select 3 pieces of candy. Now, if you've done it by hand, you would have wound up canceling a lot and multiplying 13 times 2 times 11 to get that 286 also. In our next video, we will look at some mixed questions on 10 through 15 in your notes. Thanks for watching.